And he didn't stop there. When Galileo realized that a small rhythmically applied force could make oscillations grow to the limit, he knew he'd discovered something else about music, the principle of resonance. As an idea, resonance wasn't as dangerous as the ones for which Galileo was eventually brought to trial. But in its own way, resonance did, and still does, produce some shattering results.
Can the amplified voice of Ella Fitzgerald shatter this glass? Believe it.
If it can be said that Galileo and his father made careers of shattering Greek traditions of science and music, it should be acknowledged that every Western scholar made progress only by climbing those ancient foundations to begin with. By the same token, if Galileo was inspired by his father, perhaps so too was Pythagoras, whose father was a gem cutter. Even today, viewing the geometrical shapes of natural crystals, one can see them as facets of the mathematical nature of nature itself. Looking deeply into the nature of just about everything, Greek philosophers perceived that matter is made up of atoms. But it would take centuries to discover that the shape of matter would reflect the arrangement of atoms. An arrangement in which atoms are bound together by the electrical potential energies that act between them. And while interactions between atoms are electrical in nature, interactions between members of the human species can be just as complex and highly charged. As demonstrated by the bitter controversy between Baron Gottfried von Leibniz and Sir Isaac Newton. Among many other remarkable distinctions, Newton was Cambridge University's representative to the British Parliament. He was not England's greatest statesman, but when it came to the behavior of masses and forces, no one laid down the law better than he did. The change of motion, he proclaimed, is proportional to the force impressed and is made in the direction of the straight line in which the force is impressed. In other words, and in modern terms, force equals mass times acceleration, which is a vector equation. About the derivative of a derivative.